Question 10. What is the burette reading for this transparent liquid? Just read it off and you should get 24.30 centimeters cubed. Volumetric flask was used prepared 250 centimeters cubed. Each reading has a certainty of that. What is the percentage of uncertainty? If we do 10.13 minus 4.48, then we do 0.005 over 10 by 100, you should get 0.09%. There's your answer. Not 0.009%. Because there's two readings, 0.18%, because we're going to times it by 2. The infrared spectrum of organic compound is shown. Which compound produces spectrum? So let's go through this now. If we go to periodic table, we scroll down here to table A. We can see here, well, this is the fingerprint region. We do not really care about this. If we look here, well, we have a peak here. The peaks point downwards in infrared spectrum, so that's what 1600, 1700, 1800, 1900. That's like 1700. There's another peak here at 3000, so 1700. Well, that has to be a C double bond O bond. The 3001 tells me that it's OH for an acid. But because it's got the C double bond O bond, it has to be. It can't be ethanol, it can't be pentuene because that's an alcohol, that's OH, and that's an alkene, C carbon, carbon, carbon double bond. So it's either butanol or propanoic acid. Alright. Now this 3000 there's a peak here. So it is going to be butanone ketone. 13A, which is most likely bond angle on oxygen atom methanol, 104.5 degrees. Which compound is structural isomer of Z-butyene? So we try to draw it out. Z-butyene. Methane, ethane, propane, butane. So methane, ethane, propane. Methane, ethane, propane, butane. So the Z isomers was when they're on the same side, so I've already done it wrong. CH3. So which one's the structural isomer of that? We draw a butane. Definitely not going to be butane. E-butyene, no, that's not going to be structural isomer of it. It's going to be cyclobutane. My answer. Which occurs in a propagation step in the conversion of trichloromethane into tetrachloromethane? By reaction with chlorine in the presence of ultraviolet light. So with a propagation step, it definitely can't be A, because there's no free radical. It definitely can't be B, because that's a termination step. And it definitely can't be C, because we would never form a hydrogen free radical in this case. So the answer is D. Question 16, which compound is the fastest rate of reaction of potassium cyanide to form pentane nitrile? Answer is D. It's because the Ci bond, the bromo, CBr, CCl, CF, Ci bond is the weakest, therefore fastest substitution. Because it's the weakest, it's fastest substitution, and therefore it's going to have a fastest rate of reaction. Which alcohol can be oxidized by acidified potassium dichromate but cannot be dehydrated with concentrated sulfuric acid? So oxidized by acidified potassium dichromate but cannot be dehydrated with heating with concentrated sulfuric acid. Let's look at 2,2-dimethyl propan 1-ol. methane, ethane, propane. Alkyl group in the first carbon. Methane, ethane, propane. 2,2-dimethyl. CH3, CH3, H, which alcohol can be oxidized, by acidified potassium dioxide, but cannot be dehydrated with sulfuric acid. If you look here, this carbon attached to this OH, what kind of carbon is this? This is a primary alcohol. So it's primary alcohol, so it can be oxidized. However, it cannot be dehydrated by heating concentrates sulfuric acid because it's only primary alcohol. Well, if we look at 2,3-dimethyl butanol, butane, OH, CH3, and the hydrogens. That is a tertiary alcohol. So that cannot be oxidized by acidified potassium dichromate. If you look at 2-methylpropanetol, methane, ethane, propane, 2-methyl propanetol, H, hydrogen, and your final hydrogen. That is a tertiary alcohol. 1, 2, 3 group. So it cannot be A, cannot be C. And if we look at pentanethol, methane, ethane, propane, butane, pentane, 1, 2, 3 alcohol groups on the third carbon. Actually, let's just put it here. Fill in the hydrogens. Methane, ethane, propane, butane, pentane. Yep. Sorry for the hydrogens being drawn very badly. And you can see again, that is pentanethol. That is a that's a secondary alcohol. So that cannot be that will not fulfill both conditions. Therefore, the answer is B. Question 18. How many structural isomers are there with the molecular formula C3H6B or Cl? It says 5. You just draw out the structures, the structural isomers. 19a. Which sample contains the most molecules? 2.10 times by 10 to the power 22 molecules of methane, 1.0 grams of oxygen, 65 milligrams of oxygen, 0.030 moles of that. The most molecules. So what we have to do is we're already given the molecules of methane. In this case, we have to find out the moles of that oxygen gas of 32, and then we need to times my answer by 6.0 to 2 times by 10 to the power 23. That's why they give us Avogadro's constant, and that will give me 1.88 times by 10 to the power 22. Do the other thing, well, milligrams to grams, so we're going to have to do 0.065 divided by 2, and then times by 6.0 to 2 times by 10 to the power 23. That'll give me 1.96 times by 10 to the power 22. And this final one, we're all going to do is 0.0300. That's the moles of it times by Avogadro's constant. And that'll give me 1.81 times by 10 to the power 22. So which one is the most molecules? It's A. So we had to do all that working out just for the answer to be A, which it already gives us the molecules of. Oh well. Which compound forms a molecular ion with a different precise molecular mass from the other three? Which compound forms a molecular ion with a different precise molecular mass from the other three? That's a ketone. Butanol ketone. That's butanol, that's got OH group. This is an aldehyde, and this is an alkane. Now if we look here, OH group for alcohols, the C double bond O, both the aldehyde and the ketone have, and the alcohol yeah, so the answer is going to be C, dimethyl propane. It's the only alkane out of the four. Hydrogen can be produced by reaction. What's the value of equilibrium constant Kc for this reaction? So, okay, this should not be worth 1 mark, at least 2. But obviously, all of these questions are worth 1 mark. So if we draw our table, I stands for initial moles, C stands for change in moles, E stands for equilibrium moles. Hopefully you guys know that by now by watching a lot of my videos. So, carbon monoxide, water, steam in this case, carbon dioxide and hydrogen. So I'm writing down products, the reactants and the products. And I'm told that 4.21 moles of carbon dioxide will mix with this, will mix with 2 moles of steam. And that's initial moles. When the reaction reached equilibrium, 1.60 moles of hydrogen had been formed. 1.60 moles of hydrogen had been formed. So we've gone from 0, 0 initially to plus 1.60. And the thing we know is with carbon dioxide and hydrogen, carbon dioxide and hydrogen both have 1-to-1 molar ratio, so that's we're gonna add 1.60 as well. Now for carbon monoxide and H2O, well, for adding 1.60 in here, we're gonna have to subtract 1.60 for the reactants. That's exactly what we do. 0.40, 4.20 minus 1.60, 2.60, and obviously the Kc equation, Kc equals products, the concentration of products, square brackets and concentration of products, over to the power of P over reactants to power of R. So it's going to be because it doesn't give us the volume. Okay, so it's going to be 1.60 times by 1.60 divided by 2.60 times by 0.40. 2.46. There we go. I know a lot of for 1 marker, but this is what it is. It says sample of 2 cm³ volume of this. What volume should be added to dilute sample of concentration of this? So sample of this has the volume of this. So you can see the concentrations. How much have we decreased by? Well, if we do 1.5 divided by 2, we're timesing by 0.75. 2 times by 0.75 will give us 1.5. So we're timesing by 0.75. Therefore, we need to do 100 times by 0.75, which is 75. Or is it actually 1.5 divided by 2? 2 divided by 1.5. Yeah, because actually it's not going to, because that doesn't make any sense, because then with that logic we're subtracting 25, which don't make sense. What we're actually going to do is we're going to do 2 divided by 1.5, which is equal to 4 over 3, and then we're going to do 100 times by 4 over 3, which will give me 133.3 recurring. However, it says what volume should be added to 100 to acid to dilute sample. Well, how do you get from 100 to 133.3? We're adding 33.3, so the answer is B. Question 23. Which gas could be in flask B? 2 CO flasks with same volume are left side by side. Flask A contains this much mole of methane, flask B contains this much mass of a different gas. Both gases are at the same temperature and pressure. Which gas could be in flask B? With the periodic table, let's find out the MRs of these. So we've got CH2, Cl2, 12 plus 2 plus 35.5 plus 35.5, 85. That's 85. HBr, hydrogen, plus Br, 79.9 plus 1, 80.9. Kr, what's Kr? 83.8. PF3, 19 times by 3 plus P, which is 31. 31 plus 19 plus 19 plus 19, 88. Now, once I've got written down MRs, now which gas could be in flask B? So with the same volume we left side by side, so we're going to have a 1-to-1 mole ratio, right? And now all I have to do is moles mass of the MR, MR is mass of moles, mass in grams, so it's going to be 0.30 grams divided by 4.0 times by 10 to the power minus 3. And if you put that on your calculator, you should get 85, and therefore the answer is A. That's the MR of CH2Cl2, A, 85. Question 24. Analysis of a sample of chemical formula that showed it contains this much moles of carbon. What mass of nitrogen was present in the sample? Okay, 0.015 moles of carbon. How do I do this? That's the number of moles of carbon. Okay, so I can find out the mass of carbon and then work out the mass of nitrogen. That's my only. That's all that I think that can happen in this question that we can try. So mass is in moles times by MR, so we're going to do 0.0195 times by the MR of carbon, which is what? Which is 12. And then whatever mass we get, we divide it by 22 times by 6. Okay, let's try this again. 0.0195 times by 12 divided by 22 times by 6. Okay, yeah, I'm not getting this. So let me check it out, what we have to do here. Because these questions can easily be repeated. And so we have to be comfortable with a lot of these questions. Obviously, there's going to be some that I'm not comfortable with as well. But then we just repeat those questions until we are. It's actually very simple. So we've got 22 carbons, carbon to nitrogen. We've got it's 22 to 6 mole ratio, yeah, and we've got 0.0195. So to find out the moles of nitrogen, it's just going to be 0.0195 divided by 22 times by 6. That'll give me 5.32 times by 10 to the power minus 3. Mass, moles is mass of MR, MR is mass. No, we're trying to find a mass. Moles is mass of MR, mass is moles times by MR. So my answer times by the MR of nitrogen. And I should get 0.0744. So yeah, the answer is 2. So use the mole ratio, got the moles, rearrange it, and we get the mass. And that is the end of multiple choice question.